All right, guys, so today we're going to start off with Chemistry 11. The very first topic we're going to cover is unit conversions. So we're going to learn how to go from one unit to another. Now, there's a bunch of SI prefixes that you'll need to be aware of. Okay, guys, as you can see on this table right here, you see this table? This table shows you all the different types of prefixes, okay? For instance, you might be aware of few of these, like kilo, K, that's 10 to the power 3. Mega, it's 10 to the power 6. Okay, giga is 10 to the power 9. Deci, you've seen that, 10 to the power minus 1. Centi, you've come across that as well, 10 to the power minus 2. Milli, 10 to the power minus 3, and so on and so forth. You won't need to memorize all these. Usually you'll have this table available to you. But how are we going to use this table, guys? Okay, so the best way to understand that is by doing a few examples. Okay, so we're going to have a look at some of the examples that's listed on your screen. All right, guys, so before we get into the questions, there's a few things I want you to know. I want you to know the regular units, okay? We're going to call it the regular units, means those are the units which we are going to normally work with. Now, regular unit for distance, as you know, is meters, right? For time, it's seconds. For mass, it's kg. But for this one, we're going to use grams, okay? For this one, we're going to use grams. Pretty much, we don't want any of the prefixes in front, okay? We don't want any of the prefixes in front. Similarly, if it's a volume, the regular unit is liters. The ones that I call regular units are the ones which don't have any prefixes, okay? And what we're going to do is, anytime they give you a non-regular unit, we're going to first have to convert it to regular, okay? And if they're asking you to convert it to another non-regular unit, we'll have to first convert it to regular, then go to the another non-regular unit. It'll make more sense when we do a few examples. So let's have a look at the first example. They've given you 3.5 times 10 to the power 5 millimeters. So they've given you this quantity in millimeters, and they're asking you to change it to meters. So they want you to change it to meters. This is the step, folks. You're going to write what's given to you. So 3.5 times 10 to the power 5 millimeter was given to you. You're going to say multiply. Whatever unit you see at the top, we want to put the same unit at the bottom. The reason for that is because we want to be able to cancel those. So remember this, guys. This is the first rule that you'll need to know. Whatever unit you see at the top, put the same unit at the bottom. Okay, and then you want to convert it to meters, right? So you want meters at the top because you want your answer in meters. And then, guys, I want you to remember this. You always want to put 1 beside your non-regular unit, okay? You always want to put 1 beside your non-regular unit. And this is millimeters, so we're going to look for milli. Guys, look over here. This is your milli, guys. See that? What's the power of milli, guys? It's 10 to the power minus 3, right here. You see that, right? 10 to the power minus 3. What this means is that 1 millimeter is equal to 10 to the power minus 3 meters. That's what it means. And the rest is easy, guys. Millimeter, millimeter cancels. And you're going to have your answer in meters. All you do is you take 3.5 times 10 to the power 5 and multiply it with 10 to the power minus 3. If you punch it in properly, you should get 3.5 times 10 to the power 2 meters. And now you have your answer in meters, folks. So there you go. We've converted from millimeters to meters. I'm going to go over this once more. You write your given quantity at the top. Whatever unit is at the top, you put the same unit at the bottom. And remember this, you're always going to put 1 beside your non-regular unit, and then you say, okay, this is milli. So what does milli stand for? It's 10 to the power minus 3. What it means is 1 millimeter is equal to 10 to the power minus 3 meter. And milli cancels, and you're going to get your answer in meters. Any questions so far? Okay, let's try another one. So in the next question, they gave you 0.0028 liters. This is what they gave you. and they said convert it to microliters. You want to rewrite this in microliters. Guys, steps are exactly the same. Okay, if you want, you can change it to scientific notation, but we haven't talked about scientific notation yet. We'll talk about it afterwards. You can just rewrite it like this. So we have these liters. As I told you, what unit is at the top? Liters. You want to put the same unit at the bottom. And you want to change it to microliters. Now, I told you, you always want to put one beside your non-regular term. And now you're going to look for micro, guys. Now we're going to look for micro right here. I see micro. Micro is 10 to the power minus 6. What that means is 1 microliter is equal to 10 to the power minus 6 liters. Do you guys understand that? What happens then? Liter cancels. And all you have to do is you have to take this number and divide it by 10 to the power minus 6. And you're going to get your answer. If you punch it in properly, you should get 2.8 times 10 to the power 3 microliters. You've converted it to microliters now. Any questions? Okay. If at any point you guys have a question, just let me know. Let's have a look at the next one. I had 3.2. Now this is megaseconds. You see this capital M? Okay. If you look for the capital M, it tells you what that is. It's called mega. So they've given you 3.2 megaseconds and they want you to convert it to seconds. All right, guys, I want you to try this one out. Let's go. I'm going to quickly go over that. All right, guys, so they had given us 3.2 megaseconds and we wanted to change it to seconds. Pretty simple. You write 3.2 megaseconds, that's given to you. Now, whatever unit is at the top, we want to have the same unit at the bottom. And we want to change it to seconds. Now, megasecond is your non-regular unit, so we'll put 1 beside it. And what does mega stand for? It's 10 to the power 6. We're going to put that at the top. That means 1 megasecond, it has 10 to the power 6 seconds in it. Megasecond cancels. So your answer is straight up 3.2 times 10 to the power 6 seconds. You've converted it to seconds. So guys, as you can see, once you understand 2 concepts, there's 2 concepts you need to know. Whatever unit is at the top, you put the same unit at the bottom. And the second concept is you always want to put 1 beside your non-regular unit. And for the regular, you look for this. Okay, you look for what power of 10 is this unit stands for. Okay, so that's simple as that.
So is the irregular unit always the unit that's already given to us?
Prefix. No, your non-regular unit. Okay, when I say non-regular unit, it's the unit with the prefix in front.
Okay. Okay.
It's the unit with prefix. Okay, and your regular unit is by itself. It's got no fancy letter in front of it. Okay, so let me just give you a few examples of your regular units. Pretty much you see meters. Do I see any fancy acronym in front of it? Any fancy letter? Nothing. Seconds? Nothing. Grams? Nothing. Liter? Nothing. Whereas your non-regular would be, let's say, micrometers, or your megaseconds, or your kilograms, or your kiloliters. See the difference? So regular units have no prefix in front, whereas your non-regular units have your prefix in front. Pretty simple. Okay, let's move on. So guys, in the next question, okay, next one is tricky. I want to see if you guys can figure this out. I have 0.0065 millimeters, and I want to convert it to micrometers. Okay, give it a shot. Okay, guys. So there's one interesting thing in this question that's a bit different than the previous ones that we've done. Guys, look, in the previous ones, we were going from a non-regular to a regular. But over here, I'm going from one non-regular to another non-regular. And that's my problem. We cannot go directly from one non-regular unit to another non-regular unit. What we have to do, okay, what we have to do is, you see this millimeters? We're going to have to first convert it to meters. And then we have to convert meters to micrometers. Does that make sense? Okay. So you cannot go from millimeters to micrometers in one go. You have to first convert it to meters, and then from meters to micrometers. You can think of your regular unit as a bridge that you need to cross. Okay. Your regular unit is a bridge that you need to cross. Okay. Let's have a look. So they gave me 0.0065 millimeters. Okay, I cannot go to micrometers directly. So what we're going to do is, you see, I have millimeters at the top. I put same unit at the bottom. But we're going to first convert it to meters. I put 1 beside my non-regular. And what does milli stand for? If you go look for milli, it's 10 to the power minus 3. What that means is 1 millimeter is 10 to the power minus 3 meters. Millimeter, millimeter cancels. Now we're at meters. We got to go from meters to micrometers. Okay, so we got to go one more step. So it's a two-step conversion. I have meters at the top. I put meters at the bottom. And I want to convert it to micrometers. Micrometer is my non-regular unit. I put 1 beside that. Now, what does micro stand for? If you look for micro, it's 10 to the power minus 6. Micro is 10 to the power minus 6. So we come over here and we say it's equal to 10 to the power minus 6 meters. So meter and meter cancels. So there you go, guys. You have to be careful now. Okay, if I was you and punching it in my calculator, this is how I would punch it in. I would put brackets. I would put these in brackets, and I'd put another bracket so my calculator knows these guys are at the top. And I put bracket at the bottom, and I punch it in. Now, if you punch it in properly, you should get 6.5 micrometers. Do you guys understand that? So this is a two-step question, folks, because we're going from one non-regular unit to another non-regular unit. So you have to go from millimeters to regular meters and then convert meters to micrometers. Be aware of that, folks. Okay? Are we good so far? Okay, excellent. All right, guys. So the next few questions that you see on the sheet, I want you guys to do those yourself. Let's go. All right, guys, let's have a look at these questions, okay? So in the first question, they've given us 5.4 times 10 to the power 6. If you convert it to scientific notation, but let me just leave it like this, 5400000, okay? And it's small letter D. Small letter D is called what? Let's have a look. That's deci. So decigrams. They've given you decigrams and they want you to convert it to megagrams. Now remember this, both of these are non-regular units. You cannot convert from one non-regular to another one directly. We have to go from decigrams to grams and then from grams to megagrams. Okay, remember that. That's the concept you'll need to know. So we have 5400, another 3 zeros, decigram. We're going to first convert it to grams. I have decigram at the top, I put decigram at the bottom, and I'm going to change it to grams. Deci is non-regular, I put 1 beside it, and what does D stands for? The lowercase d. It's 10 to the power minus 1. Okay, decigram cancels. So now I have it in grams, but I want to convert it to megagrams. So I put grams at the bottom and megagrams at the top. Megagram is non-regular. I put 1 beside it. And what does capital M mega stand for? 10 to the power 6. Okay. So grams cancels now. So your answer should be 5400000 times 10 to the power minus 1 divided by 10 to the power 6. You have to be careful when you punch it in and put brackets. I would put another bracket so my calculator knows which guys are at the top and which guys are at the bottom. If you punch it in properly, you should get 5.4 times 10 to the power minus 1 megagrams. Do you guys understand this? Okay, let's have a look at the next question. In the next question, they've given me 0.032 gigahertz, and they want me to convert it to kilohertz. Now, guys, again, we're going from one non-regular to another. Okay, so for that, you're going to have to go from gigahertz to regular unit, which is hertz, and then from hertz to kilohertz. Remember, hertz is the unit of frequency, okay? So we have 0.032 0.032 gigahertz. Let's convert it to hertz. So we put hertz at, it's gigahertz at the top. We put gigahertz at the bottom and hertz at the top. This is the non-regular. You put 1 beside it. And capital G, giga, stands for 10 to the power 9. So this is equal to 10 to the power 9 hertz. This cancels. Now we got hertz at the top, and we're going to put hertz at the bottom. And we want to go convert it to kilohertz. This is the non-regular. I put 1 beside it. Now what does kilo stand for? Kilo is 10 to the power 3. So we can say 1 kilohertz is 10 to the power 3 hertz. Now hertz cancels. So you would punch it in your calculator like this, folks. It'll be 0.032 times 10 to the power 9 divided by 10 to the power 3. Make sure you put another bracket so your calculator knows which guys are at the top and which guys are at the bottom. If you punch it in properly, you should get 3.2 times 10 to the power 4 kilohertz. Any questions so far? Okay, good. Let's move on to the next one now. So what do we have next? In the next question, they've given me 0.025 ml, milliliters, and they want me to convert it to lowercase nl. That's called nanoliters. Okay, so again, we cannot go from one non-regular to another. We have to go from milliliters to regular, which is liters, and then we'll go from liters to nanoliters. Okay, so what do we have? We have 0.025 ml. I put ml at the bottom, and we're going to change it to liters. ml is non-regular, put 1 beside it. What does lowercase m stands for? Milli, 10 to the power minus 3, which means 1 ml is 10 to the power minus 3 liters. Okay, ml cancels. Now I have my answer in liters. But I want my final answer in nanoliters. So I have liters at the top, I put liters at the bottom. We want to convert it to nanoliters. So you put nanoliters at the top. This is non-regular, you put 1 beside it. And what does nano stand for? Nano is 10 to the power minus 9. So 1 nanoliter is 10 to the power minus 9 liter. Liter cancels now. So you would punch it in like this in your calculator. 0.025 times 10 to the power minus 3 divided by 10 to the power minus 9. Put extra brackets. If you punch it in, you should get 2.5 times 10 to the power 4 nanoliters. Does anyone have any questions on this? Are we good, folks? Okay. Excellent. Next up, we have 0.056 grams per second. And they want me to change it to grams per minute. Okay, so let's write this. We have 0.056 grams per second, means you can say per 1 second. They want me to change it to grams per minute. So grams is fine at the top, but I want to convert seconds to minutes. So guys, now look, seconds is at the bottom. You have to put seconds at the top. And you have to put minute at the bottom. You see, it's grams per minute, so we need minute at the bottom. But to cancel the seconds, I'll put seconds at the top. And guys, 1 minute has how many seconds? It has 60 seconds. So what happens? Seconds cancels. And now you just do 0.056 times 60. And that should give you 3.36. And now your unit is grams per minute, folks. Does that make sense? Do you guys understand this? This one's a bit different than the previous one. So I want to make sure you guys fully understand this. Okay. Good. So what do we have next? We have 345 micrograms per liter. And they've asked us to convert it to milligrams per ml. Okay, guys, so this is a bit tricky because we're changing micrograms to milligrams. We're changing liters to milliliters. So this one's going to require a fair bit of steps. Okay, so let me write that. Let me write that over here. Okay, we'll tackle this over here. All right, guys, so we're going to write 345 micrograms per liter. You can say per 1 liter. First thing what I'm going to do is I'm going to convert micrograms to milligrams. Well, you know we cannot do that in one go. I have micrograms at the top. I'm going to put micrograms at the bottom. I'm going to change it to grams first. This is non-regular. I put 1 beside that. 1 microgram is 10 to the power minus 6 grams. Why? Because as you know, micro is 10 to the power minus 6. Right over here, you will see micro is 10 to the power minus 6. Okay, but we need milligrams. So now I'm going to convert grams to milligrams. So I have grams at the top, I put grams at the bottom. And I put milligrams at the top. This is non-regular. I put 1 beside that. And what does milli stand for? Milli is 10 to the power minus 3, right here. Milli is 10 to the power minus 3. So 1 milligram is 10 to the power minus 3 grams. Grams, grams cancels. Microgram, microgram had canceled there. And now we finally just need to change from liters to milliliters. I have liter at the bottom, so I put liter at the top. And I have to convert it to milliliters, which needs to go at the bottom. And guys, this is non-regular. I put 1 beside it. And milli is 10 to the power minus 3. So I say 1 milliliter is 10 to the power minus 3 liters. Did you guys understand that? So what happens now? Your liter cancels. So what do you need to punch it in your calculator? So all the top guys first, which is 345 times 10 to the power minus 6 times 10 to the power minus 3. I would put another bracket so my calculator knows which guys are at the top, divided by 10 to the power minus 3. If you punch it in correctly, you should get 3.45 times 10 to the power minus 4, and it's milligrams per ml. Do you guys understand the steps here? Okay, this was a challenging question because we had to convert the top and the bottom, and the top one actually had 2 steps. Okay, do me a favor, folks. You're going to redo this question again. Let's go. All right, guys, now we're going to talk about significant digits, sig figs. Okay, but before we do that, I want to make sure you guys know how to convert numbers to scientific notation. Okay, let's talk about scientific notation first. When do we use it and why do we need it? So guys, if I give you a number like 5430000, you see, it's really inconvenient writing this whole number over and over again. What you can instead do is you can turn it to scientific notation, okay? And in scientific notation, all we do is we put the dot after the first number. So it will be 5.43. And now we don't really need to write these 0000 because these are kind of insignificant at this point. All you do now is, guys, we're going to say multiply by 10 to the power. And to identify this number, this is what we do. Whenever you see a number like this, it means the dot is at this point right now. So you count how many places do I need to move it to get it to this point right here. So let's see. 1, 2, 3, 4, 5, 6. You moved it 6 places to the left, so it will be 10 to the power 6. So that's how you convert it to scientific notation. Do you guys understand that? Okay, let me give you another one, 23700. Okay, you want to write it as scientific notation, you want to put the dot after the first number. So 2.37, don't worry about the zeros, times 10 to the power. Right now my dot is here. Right now my dot is here. 1, 2, 3, 4. I moved 4 places to the left, so it's 10 to the power 4. And guys, remember this, okay? You see, these numbers are really large numbers. These numbers right here are large numbers, so their powers are going to be positive, okay? The power of 10 is going to be positive. Keep that in mind. So we were over here, 1, 2, 3, 4, 5, 6. Move 6 places to the left, so it's 10 to the power 6. For this one, I was right here. So you move 1, 2, 3, 4, 10 to the power 4. Okay, let's see if you guys can tell me the next one, folks. What about 5,000? So you would say 5 times, I mean, you can put the dot here, right? But you see these zeros don't really matter, so you don't need to write that in this case. We'll talk about that in scientific notation. Right now the dot is here. So 1, 2, 3, 10 to the power 3. Sometimes they might trick you. They might give you numbers like 52.3 times 10 to the power 5. Okay, this is not in proper scientific notation because your dot needs to be, your decimal needs to be after the first number. So it should be 5.23 times. Now, how many places did you have to move? 1. So you'll have to add 1 to this power. So it will be 10 to the power 6. Are you guys understanding this so far? Okay, what if I give you 4237.25 times 10 to the power 3? Now guys, this is incorrect. You'll never see a number written like this, but this is just to test your understanding. Okay, well, let me just put zeros here. Let me just put zeros here. Okay, guys, so you want the number, you want the decimal after the first number. So it should be 4.237 times 10 to the power. Now, it was over here. How many places did I move? 1, 2, 3. So you should add 3 to this power. So it should be 10 to the power 3 plus 3, which is 6. All good so far? Okay, now in these cases, we were moving the decimal to the left, right? Because these were large numbers. These are all big numbers. Anytime your number is greater than 1, the power will be positive. But what if your numbers are less than 1, means it's some decimal like 0.0052? Again, you would say you want to put the decimal after the first proper number. So it should be 5.2 other than 0. First number other than 0. So it should be 5.2. Now, how many places do I have to move? 1, 2, 3. But this is 3 to the right. So it will be 10 to the power minus 3. Another way of thinking about it is, it's a really small number, way smaller than 1, so the power is going to be negative. Let me give you another one. What if I give you 0.010? So you should say it should be, move it after the first non-zero number, so it should be 1.0 times 10 to the power 1, 2. Okay. What if I give you this? Can you guys tell me how would you convert it in scientific notation? All right, guys, let's have a look at this one. So we have 0.00437. I want to write it in scientific notation. So you want to move this decimal after the first non-zero number, which is 4. So it should be 4.37 times 10 to the power 1, 2, 3. But it's 3 to the right, so it should be 10 to the power minus 3. Guys, a practical way of thinking about it is, this number is really small. It's less than 1. So the power is going to be negative. All good so far? You guys are good with scientific notation?
Yeah.
Okay, good. All right, guys, now we're going to talk about significant digits, okay? Or sometimes they're called sig figs. There's a couple rules you need to know. I'm going to start listing them. If you see a number like this, 323, and I ask how many sig figs are there? You just count the numbers. You just count the digits. 1, 2, 3. So sig figs are 3. Okay. I'm going to write my sig figs here. So that number has 3 sig figs. What if I give you 3230? Well, you see, because there's no decimal, the 0 at the end does not really count in sig fig. So your sig figs are just 1, 2, 3. You only count the non-zero numbers as long as there's no decimal. So it should be 3 as well. Are you guys good so far? Okay, what if I give you 4207? Okay, now this 0 is between 2 non-zero numbers, so it's going to count. So in this case, it will be 1, 2, 3, 4. Your sig figs are going to be 4. Are you guys understanding this so far? Okay, now, what if I give you 3.230? Okay, now you see a decimal, right? If you ever have a 0 after a decimal, it matters. It counts because it gives me a better idea about the accuracy. So it will be 3, 1. Okay, how many sig figs are there? 1, 2, 3, 4, because 0 counts as well. Keep that in mind. If you ever have a 0 after the decimal, then it counts. But if you just have a 0 without any decimal, it's not going to count. Do you guys understand this so far? Okay. How many sig figs are there, folks? The 0 is after the decimal. It counts. This counts. Everything in between counts. 1, 2, 3, 4, 5. 5 sig figs. What about this? This is a tricky one. Now, I told you that zeros after the decimal matter. They count. However, if it needs to have a number in front, does this 0 have any non-zero number in front? Does this 0 have any non-zero number in front? No, it does not. So this one does not count. So the only ones which count are these, this number, this digit, and this digit. So your sig figs are only 2. This one and that. This 0 does not count, even though it's after the decimal, because there's no other non-zero number outside the decimal, to the left of the decimal. Okay, so far so good. Are you guys understanding this? Okay, what if I give you this? 2.0. How many sig figs are there? 0 after the decimal counts. So 1, 2. What if I give you just 3? There's just one number, so it's that. Now, sometimes they might give you numbers as scientific notation. So it could be 3.23 times 10 to the power 7. You don't really worry about this. You just look at these numbers. 1, 2, 3. 3 sig figs. What if I give you 4.20 times 10 to the power 3? Again, you just look at these. This 0 is after the decimal. It's going to count because there are other non-zero numbers in front. So 1, 2, 3. Are you guys understanding this? How many sig figs are there, folks? Tell me.
2.
Excellent. These zeros after the decimal are not going to count. Why? Because there's no non-zero number in front. So the only sig figs are these, this and this. This 0 counts because it has the 2 in front. So you have 2 sig figs. You need to know that, folks. Okay, you need to know that. So let's go back and practice some questions around sig figs. Okay, I'm going to write down the numbers. I want you guys to tell me how many sig figs are there, okay? And I want you guys to be quick. I have 0.00230. Tell me the number of sig figs.
3.
Excellent. 1, 2, 3. These zeros don't count because they don't have a non-zero number in front. What about this one? How many sig figs are there?
2.
2. Exactly. These zeros are not going to count. There's no decimal here. So 3 and 9 are the only sig figs. Next I have is 1.002 times 10 to the power 5. How many sig figs are there?
4.
No. You see, 1 is a sig fig, 2 is a sig fig. So everything in between is a sig fig. So 1, 2, 3, 4. There are 4 sig figs.
I said 4.
See? Oh, you said 4. Okay.
Yeah.
For some reason I just said 1.
Oh.
Yeah. I was wondering too. I was like, why did he say 1? Okay, good. Excellent. What if I give you 3.2000 times 10 to the power of minus 4? Okay. How many sig figs do we have, folks?
2.
2.
Zeros after the decimal are going to count.
5.
1,
5.
2, 3,
Okay.
4, 5, 5 sig figs. Be careful about this, folks. I've seen many people, they lose marks on sig figs because there's a bunch of confusing rules there. Okay, zeros after the decimal count as long as there's a non-zero number in front. So it's actually 5. Okay. Next up I have is 500,020.0. How many sig figs do we have now?
5.
This is a tricky one, guys. This is a tricky one. How many Cyclics? Excellent. Guys, this is the Cyclic. And you know, 0 after the decimal is a Cyclic because it has a bunch of non-zero numbers in front. So everything in between counts. 1, 2, 3, 4, 5, 6, 7. 7 Cyclics. So far, so good, folks. What if I give you 345?
3.
3.
Excellent. Super simple. So there you go. These are the rules to determine the number of Cyclics. Okay, excellent. Now, we're going to learn how to multiply two numbers and how to work with Cyclics. Okay, so Cyclics, multiplication and division rules. Multiply and division. Remember that, folks. So remember, this multiplication and division has different rules than addition and subtraction. We're going to come across that. So guys, if I give you a question like this, let's say I have 2.15 times 0.0034. And I say, you know what, guys, multiply these numbers and give me the answer in proper Cyclics. So what you want to do is, firstly, just blindly punch it in your calculator. Punch these numbers in blindly. Don't worry about any Cyclics yet. Tell me, what do you get? I got 7.31 times 10 to the power minus 3. Did you guys get that?
Yeah.
Okay. So now we need to worry about the Cyclics. So this is what we do. You ask yourself, how many Cyclics do I have in the first term? How many Cyclics are there, folks?
3.
3. How many Cyclics do I have in this term?
2.
2. Okay. Guys, whenever you're multiplying or dividing, your answer should have the minimum number of Cyclics out of those two numbers. Okay. So you would want to use the least Cyclics of all the numbers that are involved in the example. So what that means is, you see 2 is the least number of Cyclics. That means your final answer should only have 2 Cyclics. So instead of 7.31, you would rewrite this as 7.3 times 10 to the power minus 3. Does that make sense? Let me give you another example. 345 times 21. Blindly punch it in. What do you get? 7245?
Yep.
Okay. How many Cyclics did we have on 345? 3. And on this one?
2.
2. So my answer should have how many Cyclics?
5.
No, the least number of Cyclics out of these two. My answer should only have 2 Cyclics.
Oh, okay. Okay.
Right? Because you got to pick the minimum, the least out of these two. So it should only have 2. Now, you see, oftentimes people get confused. They say, how do I write this as 2 Cyclic? You can't just make it 72, because this is 7,245. That's not equal to 72. That's way off. So it's going to be 72. If you want only 2 Cyclics, should be 7200. Okay. Now this is difficult to envision. This is difficult to think about. So for that, what I do is, I always, anytime I get a large number or a small decimal, I convert it to scientific notation. So how would you rewrite this guy as scientific notation? You would say it's 7.245 times 10 to the power, right now my decimal's here, 1, 2, 3. Agreed. Right? You can rewrite this guy as that. How many Cyclics are you seeing on this? I'm seeing 4. My answer should only have how many?
2.
2.
2. So you would rewrite this as 7.2 times 10 to the power 3. And there you go, guys. Now you only have 2 Cyclics. And this can be written as 7200. So had you left this as 7200, that would have been fine too, because this is same as that. Do you guys understand that? But I always convert it to scientific notation. It makes my job easy. Do you guys understand?
But for the first one, it only took 1 Oh, we're not supposed to take 2 out?
No. Okay, look. How many sig figs are there in 2.15?
3,
How many sig figs are there in 0.0034?
2.
2. My answer should only have the least out of those two. So my answer should only have 2 sig figs, correct?
Yeah.
Right now I have 7.31. That's 3 sig figs. How do I change it to 2 sig figs? Get rid of this guy. Just write it as
Okay.
7.3.
Okay, got it.
Right? So
Yeah.
that's how you're going to approach these questions.
Yeah.
We're going to do more examples. Okay? So same for division, guys. If I give you 2500 divided by 8, punch it in your calculator. Tell me what your answer is. 2500 divided by 8 gives you how much? 312.5?
Yeah.
Yeah.
How many sig figs are there in 2500?
4.
2? No.
Oh,
Those
the
zeros don't count. Exactly. How many sig figs are there in 8? 1. So my answer should have how many sig figs?
1.
1.
So how would you turn this so that it only has 1 sig fig? What's this
8.
close to? 300. Right? Or what you could have done was, because you see, thinking about this is a bit challenging. You could have changed this guy to scientific notation, like 3.125 times 10 to the power 1, 2. 10 to the power 2. Now you realize that this guy right now has 4 sig figs. I only need 1 sig fig. So you would just rewrite this as 3 times 10 to the power 2 as your final answer, which is equal to 300. That's how you tackle the sig figs in multiplication and division. Are you guys understanding this?
Sort of.
It will, it will require some practice. It will definitely require more practice, but that's the gist of it. What you need to know is, if you're multiplying or dividing the numbers, you're going to use the least sig fig of any number that's involved in the calculation. Okay, so let me give you another example. What if I give you 325 times 89 times 5 divided by 2? Just blindly punch it in your calculator. So do 325 times 89 times 5 divided by 2. It gives you 72312.5. Do you guys agree?
Yeah.
So you say, okay, how many sig figs do I have in this number?
3.
3. What about this?
2. 1.
What about this? What about this?
1.
What's the least sig fig that you see in all these numbers?
1.
So my answer should only have 1 sig fig. Can you tell me how would you turn this number so that it has only 1 sig fig? Well, only 7 will matter. Everything else will become 0. So it will be 7, 0, 0, 0, 0, 70,000, right? Another way you could have approached this question was by writing this as scientific notation first, which would have been 7.23125 times 10 to the power 1, 2, 3, 4. So you say, I only need 1 sig fig, so I only need this guy. So you can rewrite this as 7 times 10 to the power 4. And there you go, guys. This matters, and either one of these is fine.
Yeah, that's what I got too.
Perfect. Excellent. So there you go, guys. A few more examples, and you'll get the hang of it. Okay. All right, guys. I have a bunch of multiplication and division questions on my screen. I want you guys to try those out. Let's go. Don't look at the answers, okay? All right, guys, let's have a look at the first one. So we have 2.15, and it's being multiplied by 0.0034. So first of all, let's just blindly punch it in. 2.15 multiplied by 0.0034, and you should get 7.31 times 10 to the power minus 3. Okay, so you realize, ask yourself, how many sig figs are there? In this number, we got 3 sig figs. And what about on this one? Well, only these guys are going to count, so that's 2. So my answer should have the least number of sig figs. So my answer should only have 2 sig figs. So this should be only 7.3 times 10 to the power minus 3. Straightforward. Next question. We have 0. Okay, that's a plus minus 1. We're going to skip that. So we're going to move on to number 3, which is 4.555 times 10 to the power 6. And we're dividing it by 2 times 10 to the power minus 2. So guys, make sure, you see how I've put the brackets over there? Always put brackets, okay? Always put brackets. So we have that, and divide that by 2 times 10 to the power minus 2. Bracket closed. And what do you guys get? I get something like 2.2775 times 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. Did you guys get that? So ask yourself, how many sig figs are there in this one? 4. How many sig figs do you see on that one? 1. So your answer should only have 1 sig fig. So this should only be 2 times 10 to the power 8. Any questions? Okay, good. Let's move on to the next one now. So on the next one, we have 8.99 times 10 to the power 3. You see, I always put brackets. Divided by 4.600 times 10 to the power minus 8. There you go. Blindly put brackets, punch it in. 8.99 times 10 to the power 3. Bracket close. Divided by 4.6 times 10 to the power minus 8. Bracket close. That should give you 1.954 times 10 to the power 11. Do you guys agree with that? How many sig figs are there? 3. How many sig figs are there? 4. So your answer should have the least out of those 2, which is 3. So it should only be 1.95 times 10 to the power 11. So far, so good. Okay. Okay, next one is 89.000 divided by 1.230 times 10 to the power 2. I always put brackets. When I punch it in, I always put brackets. Okay, guys, remember this. Brackets are your friends. They are your best friends. Okay, you're going to avoid losing lots of marks if you put brackets all the time. Make it a habit. So when you punch it in, you should get 0.723577. I get 0.723577. Let's rewrite this in scientific notation. So it will be 7.23577 times 10 to the power. I move 1 to the right, so 10 to the power minus 1. Ask yourself, how many sig figs do we have here? Well, that's 1, 2, 3, 4, 5. And on here, that's 1, 2, 3, 4. So my answer should have the least out of those 2, which is 4. So I would say this should be 7.23. Now, normally I would write 5, but you see this number 7, so 5 will get rounded up and it will become 6. So it's 7.236 times 10 to the power minus 1. Okay, simple stuff. Multiplication and division sig fig is super simple. Let's try the next question where we have 0.000020 times 245.912. We're going to multiply them. 0.000020 times 245.912. Blindly punch it in, and you should get 4.918 times 10 to the power minus 3. So ask yourself, how many sig figs do I have here? 1, 2. These zeros don't count. 2. And on here, that's 1, 2, 3, 4, 5, 6. My answer should have the least out of those 2, which is only 2. So this should be 4.9 times 10 to the power minus 3. Does anyone have any questions? Okay, so that's how you're going to tackle your multiplication and division questions. That's how you're going to tackle your multiplication and division questions, okay? If you have any questions at this point, guys, just let me know. Are we good so far? All right, guys. So on this sheet, I'm going to pick a few questions, and I'm going to ask you guys to do those. All right, guys. Let's go through these questions. We're going to start off with question number 9. Okay. So what do we have in question number 9? Question says we have 1.0000 times 10 to the power 5. You see how I put brackets around them? Multiplied by 2.3569 times 10 to the power 7. It's crucial to put brackets, folks, okay? So let's blindly punch it in. If you punch it in, guys, you will get something like 2.3569 times 10 to the power 12. Okay, so we ask ourselves, how many sig figs are there on this one? 1, 2, 3, 4, 5. What about on this one? 1, 2, 3, 4, 5. So we got 5 sig figs on each one. So my answer should have the least, but in this case, it's all the same. So my answer should have 5. So 1, 2, 3, 4, 5. It already has 5. That's my final answer. Did you guys get that?
Yeah.
Yeah.
Okay. Let's have a look at number 14 now. We have 8695.23. And we're multiplying this with 0.000120. 300. So let's blindly punch it in into the calculator first. So we have 8695.23 multiplied by 0.000120,300. That gives me 1.0460. Okay, 1.46036. Let's just write a few more decimals there. Ask yourself, how many sig figs are there? 1, 2, 3, 4, 5, 6. And what about on this one? Well, I have 1, 2, 3, 4, 5, 6. So my answer should have 6. How many do I see over here? 1, 2, 3, 4, 5, 6, 7. I have 7. So I got to reduce it by 1. So 1.460, and instead of 3, I round it up because this is 6. I round it up to 4. So there you go. My answer should be 1.04604. Okay. So far, so good, folks. Let's have a look at the next question. In the next question, number 25, we have 9.356 multiplied by 3.325. And we're dividing it by 21.300. Okay? So let's go. Let's punch it. Make sure you put brackets, right? Make sure you put brackets and punch it in and see what you get. So we have 9.356 times 3.325. We divide it by 21.3. This leaves me with 1.460502. Okay, let's look at the sig figs. How many sig figs are there? 4. How many sig figs are there? 4. How many sig figs are there? 1, 2, 3, 4, 5. My answer should only have 4. So it should be 1.46. And instead of 0, I round it up. 1. So that's your final answer with just 4 sig figs. Any questions so far? Okay, good. Number 27 now. We have 12.356 multiplied by 0.9987. And we're dividing it by 2.356. So let's first punch it in. So 12.356 multiplied by 0.9987 divided by 2.356. Leaves me with 5.23766. 5.23766. Let's count the sig figs. How many sig figs are there? 5. On here, 4. On here, 4. My answer should have only 4 sig figs. So this should be 5.23. And instead of 7, we round it up to 8 because there's 6 after. Okay, should be pretty simple. I'm just going to do the last question now, which is number 39. So we have 85.36. And we're going to divide it by 9.0. You see there's a bracket there? And then we're multiplying this with 0.00356. We put another bracket there. With multiplication and division, you don't need to worry too much about it. You just go 85.36 divided by 9.0, and then you multiply it with 0.00356. This should give you 0.033646. Now let's look at the sig figs. On here, I have 4 sig figs. On here, I have 2 sig figs. And on here, I have 1, 2. Okay, these ones are not going to count. Why? Because there's no number in front other than 0. So this one has 1, 2, 3, only 3 sig figs. So this one has the least out of all of those. So my answer should have only 2 sig figs. Okay, this right now, let's rewrite this in scientific notation first. So this should be 3.37646 times 10 to the power 1, 2. 2 to the right, so it'll be 10 to the power minus 2. But I need only 2 sig figs. So guys, I only need 2 numbers after the decimal. So this should be 3.3, but this is 7. We round it up to 4. 3.4 times 10 to the power minus 2. That's your answer. Does anyone have any questions on this?
No.
Okay, good. So you guys are good with multiplication and division now. All right, now we're going to move on to addition and subtraction. Okay, we're going to talk about the sig fig rules for addition and subtraction. Let's look at a few examples first. If I tell you that I have 9.26 and I'm trying to add 3.2 to this, or 3.5, let's say, guys, blindly punch it in. 95.26 plus 3.5 is how much? This should give you 98.76. Do you guys get that? Okay, now when it comes to addition and subtraction, we don't look at the sig figs. We look at the numbers after the decimal. We look at numbers after decimal. Keep this in mind. So this is a bit different than your multiplication and division. How many numbers are after the decimal on this? 2. How many numbers are after the decimal on the second one? 1. My answer should have the least. Answer should have least number after the decimal. Least out of all the numbers involved.
So it would be 98.8 then.
Absolutely. You would rewrite this as 98.8 because 7 will get rounded up. So keep this in mind. When it comes to addition and subtraction, your rules are a bit different. You're only looking at the numbers after the decimal. Does that make sense? Okay. Let's have a look at, I'm going to give you guys a few more examples here. Okay, what if I give you 253.897 plus 23.1? Okay, first of all, you would just blindly punch it in. You would say 253.897 plus 23.1. This gives you 276.997, correct? So we need to see the numbers after the decimal for both the numbers. 3 numbers after the decimal on this. We have 1 number after the decimal. So my answer should only have 1 number after the decimal. So this will actually become 276. Now, you would make this, it will get rounded up. So this will actually become 277.0. That's how you would write 1 number after the decimal. Do you guys understand that? Okay. Let me give you another example. What if I give you 963.25 plus 3? What would this be? So just punch it in. 963.25 plus 3 gives you 966.25. 966.25. How many numbers are there after the decimal? 2. How many numbers are there after the decimal? 0. My answer should have no numbers after the decimal. So this should be just 966. What if I have more than one? What if I have 925.376 plus 20 plus 2.55 plus 8? So you add those up first. So 925.376 plus 2.55 plus 8. Add them up. You get 935.926. Now let's check the numbers after the decimal. 3 numbers are there after the decimal. 2 numbers are there on this, and this one has none. So the answer should have none, no numbers after the decimal, least out of all the numbers involved. So this will get rounded up to 936, and you'll put no numbers after the decimal for that. Do we have any questions? Okay. All right, everyone. I'm going to pick a few questions for you guys on the sheet. Now I want you to try those out. All right, guys, let's have a look at these questions. So number 13 had 7.986 plus 10.2 plus 1.02 plus 3.256. As a first step, just punch it in the calculator. So you would have 7.986 plus 10.2 plus 1.02 plus 3.256. This gives you 22.462. 22.462. Now, how many numbers are there after the decimal on this? 3. On this, 1. On this, 2. On this, 3. So the least is 1. My answer should only have 1 number after the decimal. You will round it up. 4 will get rounded up to 5 because of 6 after that. So this will just be 22.5. Did you guys get that? Okay.
Yeah.
Excellent. Next question is 1.0256 plus 1.2356 plus 1.2000. Okay, let's punch it all in. So we have 1.0256 plus 1.2356 plus 1.2123 This gives me 3.4612. Number of digits after the decimal were 4. Number of digits after the decimal were 4. This one also had 4. My answer already has 4, so we're perfect. We're good for that. Number 17. Oh, that's a lot of zeros. 0.000008 plus 0.001 plus 0.0000009. Okay, that's let's add them up. 0.00008 plus 0.001 plus 0.123456 This leaves me with 1.0089 times 10 to the power minus 3. Okay, so we want to look at the numbers after the decimal. This one had 1, 2, 3, 4, 5, 6. This one only had 3. This one had 1, 2, 3, 4, 5, 6, 7. My answer should only have 3. So you would say it's 1.009 times 10 to the power minus 3. Do you guys understand that? Okay. So that's that. Next up, the next one's easy. Okay, you should be able to do number 19 yourself. Same goes for number 20. Let's look at number 36. So we have 4.2536 plus 5.3, and that's in brackets, minus 7.2536. Okay, guys, now this is a bit different. We have to tackle the brackets first. So we will first do 4.2536 plus 5.3. 4.2536 plus 5.3 gives you how much? This portion right here, this is equal to 9.5536. Okay, but now we need to tackle the Cyclics. I mean, numbers after the decimal. This one had 4 numbers after the decimal. This one only has 1 number after the decimal. So this answer that I got for these should only have 1 number after the decimal. So this should actually become 9.6. This will become 9.6. And now we will do 9.6 minus 7.2536. So when you do 9.6 minus 7.2536, you get 2.3464. Now you use the rule again. This one only has 1 number after the decimal. This one has 4. So your answer should only have 1 number after the decimal. So final answer is 2.3. That's how you tackle that, folks. Okay, you do the internal brackets first. Then you use your addition and subtraction rule on that. Once you get that, then you subtract it with this, use your rule again. Any questions? Okay, number 37. Number 37 has 85.659 minus 79.0256 plus 12. So as explained before, we will first tackle the numbers inside the bracket. So let's punch it in, folks. 85.659 minus 79.0256. This leaves me with 6.63. It's 6.6334. Let's count the numbers after the decimal. This one has 3. This one has 4. My answer should only have 3. So this will become 6.633. And then we will add 12 to that. When you add 12 to that, you get 18.633. But then when you use the rule on here, you have 3 numbers here. This one has none. No numbers are there after the decimal. So your answer should have no number after the decimal. 18.6, you will round it up to 19. And that has no number after the decimal. That would be your final answer. Do you guys understand the steps on here? Okay, good. Last question, number 40. Let's give it a shot. So number 40, or 39, sorry. That question has 78.2365. We're adding 2.3 to that, and these two are inside the brackets. And then we're going to subtract 80. So 78.2365 plus 2.3 is how much? That is 80.5365. Now, how many numbers were there after the decimal on this? 4. On this, only 1. My answer should have only 1. So this will become 80.5. And then we're subtracting 80 from it. So this will actually become 80.5 minus 80. 80.5 minus 80 is how much? 80.5 minus 80 will give you 0.5. But, guys, look over here. How many numbers are there after the decimal? 1. On there, none. So you should have no number after the decimal. 0.5, you will have to round it up to 1. And it has no numbers after the decimal. And that would be your final answer. So guys, as you can tell, these addition and subtraction questions, they're a little bit more complicated than multiplication and division. So I want you to put greater emphasis on these ones, okay? Make sure you recap all of these questions. Are we good?